In this video, we will explore the rule when raising a power to a power, multiply the powers. Let's begin by considering this expression, r squared to the fourth power. It's important to recognize that when we apply this rule, we must be raising a power, and only a power, to a power. In other words, there can be nothing else in parentheses except for an exponential expression, like r squared. In this case, we do have just an exponential expression in the parentheses, so we can apply this rule. When raising a power to a power, multiply the powers. So in this case, it's fairly simple. All we do is keep that base, r, and multiply the powers. The powers here are 2 and 4. So this is going to be r to the 2 times 4 power, which is r to the 8th power. Let's take a look at how we can find this rule, how this rule came about from the definition of an exponent. Here, inside the parentheses, we have r squared, and r squared could be written as r times r. So all I've done is taken what's inside the parentheses, r squared, and rewritten it using the definition of an exponent, but I'm still taking that quantity and raising it to the 4th power. Next, I can raise this quantity to the 4th power, r times r to the 4th power. That means I'm going to take that quantity and multiply it by itself 4 times. I should say use it as a factor 4 times. So I'm using r times r as a factor, things being multiplied 4 times. Looking here, I'm noticing that the only operation going on here is multiplication, which means that I can use the associative property to get rid of these parentheses. I can change the order of multiplication. The parentheses really don't matter here. So this is really just r times 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 r. And noticing here I have 8 different factors of r being multiplied together, which I can write as r to the 8th power. Notice that this is the exact same thing that we got when we applied the shortcut rule. Just like any rule of exponents, this rule of exponents allows us to save a lot of time. Now in this case, we could have worked it out like this without wasting too much time, but consider this example. If we had r to the 50th to the 100th power, using this method is going to take a long time to simplify here, but using this one, it becomes very easy. All I have to do is multiply the exponents. So this would be r to the 5,000th power. All I had to do is multiply those exponents. 50 times 100 is 5,000. Now let's consider another example. This is d squared to the 3rd power to the 5th power. Here I have exponents. I'm raising exponential expressions to powers, but I have multiple sets of grouping symbols. Generally, the rule when working with multiple sets of grouping symbols is to work from the inside out. There's nothing I can do on the innermost set of parentheses. I can't really simplify d squared. So I'm going to work my way out, and notice that I'm raising d squared to the 3rd power. d squared is a power, and I'm raising it to a power. So here I'm raising a power to a power, so I can multiply the powers. This is going to be d to the 2 times 3 power. And then everything on the outside of that still needs to come straight down, so I'm still raising it to the 5th power. I can simplify d to the 2 times 3. 2 times 3 is 6. So this is d to the 6th to the 5th power. I still have grouping symbols, and inside the grouping symbol I have just a power, d to the 6th. And I'm raising that power to a power, so I multiply the powers. d to the 6 times 5, which is d to the 30th power.